Graham's law of effusion. If a gas is composed of two different gas particles, different elements, different molecules, they'll both be at the same temperature. Therefore, they'll have the same average kinetic energy. We defined that earlier on in this unit. So kinetic energy 1 equals kinetic energy 2 of the two different particles. We substitute in the equation for kinetic energy, and we divide out the 1/2, and we get this. This is an inverse relationship, very similar to Boyle's law. Okay, so that means if one value goes up, for example, if mass goes up, the velocity will go down. So the heavier the mass of a particle, the smaller the velocity of the particle. Kind of makes sense. If you're applying the same force to a heavy object compared to a light object, it's a lot easier to get the light object moving faster. So that's an inverse relationship, just like Boyle's law. It's cool how the math kind of works the same for very different concepts. Here's a sample of different molecular velocities of gases at the same temperature and pressure, of course. So we have helium, which is 4 grams per mole. There's its average velocity. And oxygen. Let's just look at those two. Notice the molar mass of oxygen is 8 times as great as helium. However, helium is not 8 times the speed of oxygen. It's only the square root of 8. So let's go back to our physics and let's write this out. We have m1 v1 squared equals m2 v2 squared. Okay, so let's take the first one as helium. So we have 4 v1 squared. And then let's take the velocity of the oxygen. The molar mass there is 32 v2 squared. Okay, and we want to find the relationship of the helium velocity to the oxygen. Well, we divide through and we find that v1 is equal to the square root of 8 times v2. I skipped a couple steps there. Okay, we divided through by 4, then I took the square root of both sides. So it is not a linear relationship. Why? Because the velocity is squared. Okay, so I'll leave that there a second. 1, 2, 3, and let me erase it so you can see the answer. And you can always backtrack on this if you want to see the math again. So there we go. Helium is 1/8 the mass of oxygen, but travels at only the square root of 8, 2.8 times the speed of oxygen.